So you've been here like for a week or a few weeks here in Taipei, and you working to do what you call the bring up with Quanta, right? So what are the details? What are the things that you do with them?
Well, Richard is the first on the
lines. I've actually been here about 3 weeks, and I had to come in first because my large portion of the laptop, well, it's not really that large, but my portion of the laptop is the embedded controller chip. And the embedded controller chip is it's the processor behind all of the other processors. It's a small microprocessor, and it handles things like figuring out if the user has pressed the buttons, like the rotate button, or the game buttons, or the power button, and especially the power button, because the power button, the EC has to go and cycle all of the various power supplies on the motherboard to turn on the processor and turn on the LCD and turn on the DRAM voltages. So there's a lot of just stuff that's hidden, and that all has to work before the rest of the team can make any progress, because obviously you can't work on the CPU if it doesn't have power.
So you actually work with a team of engineers over there at Quanta, and what are the, like, how do you test these things, and how does do you plug in some things there and you see what happens? And
yeah, sometimes you turn the machine on with your software and see if it does what you expect, and obviously the things that you would expect are the lights will come on and the power supplies come on, and if you plug in a USB key, you want to be able to boot from it or load files from it, or if you plug in audio, you want to be able to get sound out of it. And so what we try to do is go through all of the devices on the chip one by one and make sure they all work. And there are several ways of doing that. You can do it at the BIOS level. We use not a conventional BIOS, but an open source one called Open Firmware. Or you can do it at the operating system level, or some combination of those. And generally what we do is, using whatever techniques we have available, we just test each of these devices, and when something is not doing like we expect, then we use oscilloscopes and other hardware techniques. So for example, today we were trying to make this display panel work. And over the weekend I was trying to make it work using Open Firmware to light up the panel and make characters appear on it, but instead of the panel appearing with a nice raster and characters, there was these like little semicircles, and those spots when they were getting really hot, you'd burn your finger. And we took that in the lab today and started probing around and trying to find why those spots were getting hot, and we found that one of the signals that was going to the panel was not in the correct voltage range, and thereby we identified that there was an error in one of the circuits, and we identified the extent of the error and a fix, which required cutting one of the microscopic traces on the board and attaching a little wire from one place to another to essentially redesign that circuit.
And then it's going to come in the next version of the board, or?
That's right. What we'll do is that all of the little blue wires, these are actually green, but they're called blue wires in the industry, all of the little blue wires will be relayed out. So they will take those changes and fold them back into the design and then produce another circuit board that doesn't have the wires.
One of the Quanta guys actually asked me about blue wires, because we called them blue wires, and because they're all green and red and yellow to them, they never blue wire. Blue wire? Why do you call it blue wire? Well, because normally they're blue, but these are green. They used to be blue. A long time ago, they were always blue.
So yeah, that's the typical thing you do, is that you try to run the software, and if it doesn't do what you expect, you then go and say, well, did I write the software incorrectly, or is this software that is supposed to work because it runs flawlessly on a similar system, and what's the discrepancy? Is it something that's changed in the design, or is it an error in the design, or am I just being stupid? And all of those things happen. Sometimes you're just being stupid.
So when is it going to work? Like the XO 1.5? Is there an official hopeful state where you arrive to the next? How long time will it take them, for example, to produce the next version of the board? Besides that,
as soon as we are comfortable that we have found all of the major flaws in the design, then Quanta will start producing another board. In fact, they may actually be started already.
Where we have an most of these fixes that are on this board will hit what's called Gerber at the end of this week. And then about 2 weeks later, we'll have another set of boards that will have all of these fixes. But then, so the first round of errors that you find are generally reasonably easy errors. I mean, you turn it on and it doesn't work, and so you figure out why it doesn't work, and then you get it working. Then you start moving more into the realm of errors that are much deeper, much harder to find. It's like every so often, once a week, it crashes. Well, why does it crash? So those verification of those systems takes much longer because it just takes a lot of times to find the errors. We may not find some of these errors until one of the other developers we get aboard to starts trying to do some things that we haven't tested, and they're like, well, every time I do this, it crashes, and so then we have to try and duplicate it, or all we've been running it right now with open. I mean, these little pads here are some little thermal heat pad stuff to try and spread the heat out. But so we really don't know what's going to happen when we put it in the XO and we get the plastic backing on it and we get the LCD on it, and the temperature that it has to run at is going to be considerably hotter. So there are all these things that come into play further and further and further, and the longer it goes, they typically turn out to be harder and harder and harder, or more involved to solve.
One thing I think that people don't appreciate these days is the staggering complexity of a computer. It's a commonplace object and you tend to take it for granted, but if you think about the number of components that are inside one of these chips, these processor chips typically will have on the order of 100 million logic elements, transistors inside them. That's a very large number, and they have to work together in very precise ways, and if anything is going wrong, you'll get a glitch. The system may crash, or it may give you an error that only shows up infrequently, and finding that is very difficult. I mean, it's the needle in a haystack problem with a very large scale factor. It's a very large, very large haystack, and the systems have become more complex at a staggering rate. So when I started my career 30-ish years ago, 68,000 processors were coming online. Okay, so 68,000, the reason for that name was because the processor had the amazing number of transistors in it, 68,000 transistors. Now we're talking 100 million. And that's a factor of 1,000. It's 1,000 times more complex. And so it becomes very difficult to find these problems.
So VIA is very, very much interested that this should work as soon as possible, I guess? Or
yes.
They're really, are they helping you?
Yes. Their engineers have been in the lab with us, and when we get stuck, we send them questions, and they will provide us with additional information about how their chip works, and in some cases a person who's an expert on a particular part of the chip, and they'll come and help us.
Do you think that the VIA solution, as being the only alternative to Intel Atom in the commercial upcoming VIA netbook market, and that's really like tiny right now, but might be bigger? Do you think that they have an interest in seeing commercial versions of the XO, perhaps? That's up to them.
I can't really speak, for their marketing plans. You might think that it would be obvious that they would. It certainly seems obvious to me, but they have to do what they have to do, and there are many business realities you have to consider before you make plans. So it's very easy to say, oh, well, so this company should do this, but in fact, you have a limited number of people, a limited amount of money that you can spend, and you have to be very careful to try to use that wisely so that you don't end up going out of business by making the wrong bet. So.
But there's a good chance that now there might be, like, as there's officially many manufacturers that want to use this chip, there's a good bet that, I mean,
it's a good process.
He has said that there's a lot of interest in using this chip, and we don't know of any other x86 alternative to, say, like the Intel Atoms. I mean, there's some ARM alternatives, and maybe we'll see some of those at the upcoming Computex. But x86, this is pretty much the only alternative right now.
All right, so cool. So thanks a lot.
Thanks.